So what we've looked at so far is a bunch of characteristics for different types of shapes. We've looked at triangles, and we've looked at different types of triangles, and we looked at parallelograms and different types of parallelograms. And so what we're going to be able to do today is look at a coordinate graph of a figure, so a figure on a coordinate graph, and be able to determine what kind of shape that is. So before we dive into that, I'm just going to do a quick review of the distance formula and the slope formula. So we have looked at this, but I just want to do a review. So this one says calculate the distance between the points with the coordinates, and then we have these coordinates. So basically what we're going to use is the distance formula to find the distance between these 2 points. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And where do we get x2 and x2, x1, y2, y1? Well, you do it like this: x1, y1, x2, y2. And so now you can go ahead and put those in. And so that would look like 4 minus -2 squared plus -1 minus 3 squared, and then you just go ahead and simplify. And so we get 36 plus 16, and that leaves us with 52. And so our distance would be the square root of 52 because there isn't an exact square root of 52. And so that's how we go about finding the distance between 2 points. So we just put those coordinates into the distance formula, and we're able to find the distance between those 2 points. Does anyone have any questions about how to find the distance between 2 points? Questions, concerns? Okay, and then whenever we're asked to find the slope like this, what is the slope of the segment? The slope formula is the slope is equal to y2 minus y1 over x2 minus x1, where we use the same x and y. And so we just plug those in. So it becomes -1 minus 3, 4 minus -2. And that gives me -4 over 6, and then simplified, -2 over 3. And so by doing so, I'm able to find the slope of the line, which basically just lets me know the rise over run or the rate of change between those two slopes. So these are all things we've looked at. Sorry. Does anyone have any questions about how to identify the slope? Any questions? All things we've reviewed before, right? Okay. Okay, so, and then just a quick reminder about the different types of triangles we've looked at. So we've looked at scalene triangles, which are triangles that don't have any congruent sides, isosceles triangles, which are triangles that have at least 2 congruent sides, equilateral triangles, which are triangles that have 3 congruent sides, and right triangles, a triangle with 1 right angle, right? So we've looked at all these different types of triangles. And so right now we're going to look at how to differentiate different triangles on a coordinate graph. So say I have something that looks like this, and it's asking me, how can we use coordinates to classify this triangle? So we want to classify this triangle as one of the following, right? And we've looked at these different types of triangles, but how can we do that? So basically the way that we can do this is we can use the distance formula to find the measures of each of the different sides. And then from there, we can see how those sides relate to each other. Are they all different? Are 2 the same and 1 different? Are they all the same? And then by doing so, we're able to classify these triangles. So I'm going to go ahead and locate the coordinates of these different vertices. That's my first step. Okay. And now that I have the different vertices, what I want to do is find the distance between each vertex. See? So like the distance between A to C, the distance between A to B, and the distance between C to B. So find the distance between each vertex for each side. And by doing so, we'll be able to classify. So say I want to start with AC. Well, I'll use the distance formula. And so therefore, I'll have 3 minus 0 squared plus -1 minus -3 squared. Right, so basically I took these coordinate points, and I'll show you which coordinate points. I took 3 and 1 and C, which was 0 and -3, and I plugged those into the distance formula, which we just looked at. Okay, and then now I can go ahead and solve. So 3 squared plus 4 squared, okay, 9 plus 16, 25. Is there an exact square root of 25? Yes, 5. It would be my perfect square of 25. Okay, so that means I know that the distance of this side is 5. Okay, now let me find the distance of the other side. So AB. Same thing, use my coordinates. So I'm going to use 3, 1, and 6, -3, right, on my vertices. So that becomes 1 minus -3, 2. And basically, I'm just using the distance formula, which we've done before, right? You can plug this into the calculator, or you can do it on your own. So 5. So this one's also 5. And then the unique thing about sides that run horizontally, so that run this way, and sides that run directly up and down, which we'll see in a bit. So one side run directly up and down, is that what you can actually do with those is you don't have to use the distance formula, but if you have a graph that kind of looks like this, where we're going by 1s or we're going by 2s, or where you can actually see and understand what we're going by, you can actually go ahead and count how many units it moves, right? So that happens for horizontal and vertical. So for this one, I could just count it. 1, 2, 3, 4, 5, 6. So this side would be 6. Okay. So now I have all this information, and what I've identified is that this side is 5, this side is 5, and this side is 6. So what does that mean? Well, that means I have 2 congruent sides, and then one side that's not congruent. So now that I'm going to look at my classifications for triangles, and I want to identify which triangle has at least 2 congruent sides. And that's my isosceles, right? My isosceles triangle has at least 2 congruent sides. Okay, so that means that this triangle is an isosceles triangle. Right? And that's how we are able to use, in this case, the distance formula to classify this triangle. And so that's the way we would go about solving for this. Okay? Okay. But say I wanted to know, okay, I know it's an isosceles triangle, but is it an isosceles right triangle? Say I wanted to know, is it an isosceles right triangle? So that's what I'm looking for. Well, the way I would identify if it's an isosceles right triangle is I want to identify the slopes and how those slopes relate to each other. So I want to identify how AC and AB are related. Okay? And so the way that I would identify those slopes is, of course, I'm going to use the slope formula. So AC, AB. And I'll go ahead and write the coordinates again just so we can identify them. And this is to identify if I have a triangle that's a right triangle. Okay, this is how we would do that. It's a little bit of a different process. So we'd start here. So 3, 1, and 0, -3. That's what I'm going to compare first. I'm going to use the slope formula. So 1 minus -3 and 3 minus 0. What does that give me? Gives me 4/3. Okay, let me try AB. 3 and 1 and 6 and -3. Plug that into the slope formula, which we looked at the beginning. 1 minus -3, 3 minus 6. And then I put that in, and I get -4/3. So how do I use that information to determine if this is a right triangle? Well, that's the takeaway here. This is what, if you're taking notes, what you want to write down. So in order for something to be considered a right triangle, the non-vertical lines, so those that don't run up and down, like we have here, they don't run like directly up and down, right? They do kind of run up and down at a slope, but they don't run directly up and down. So those two non-vertical lines are perpendicular, so they intersect at a right angle. Non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. So basically, if we want to determine if something is a right triangle, then the two slopes of the non-vertical lines need to be negative reciprocals. So that's what we're identifying here. Sorry, oops. Okay, give me 1 second. One second, guys, sorry. Okay. And so I want to identify if these two are negative reciprocals of each other. Well, let me start with 4 over 3. Well, in order for something to be a negative reciprocal, we have to switch them. So it becomes 3 over 4. But then you must also negate it. So negative 3 over 4. So a reciprocal is doing the switch. And then a negative reciprocal is switching the sign. So in order for it to be a negative reciprocal, here we would have had to have gotten a negative 3 over 4. Okay, same thing here. If I want to look for the negative reciprocal of this, I'm going to switch it 3 over 4 and then change the sign. So I would have had to have had a 3 over 4. Okay, and so because these are not negative reciprocals of each other, then this triangle is not a right isosceles. So whenever we're trying to identify if something is a right triangle, what we want to make sure is the non-vertical lines, their slopes are negative reciprocals. Okay. Any questions about this? And we'll look at some examples later on, but any questions right now? So by using the distance formula, we determined that this triangle is an isosceles triangle. And then by using the slope formula, we were able to determine whether or not that isosceles triangle was also a right isosceles. Okay, any questions? Okay. And so next thing, so we looked at different quadrilaterals and different parallelograms. Right? We looked at parallelograms, which is a quadrilateral with both pairs of opposite sides parallel. We looked at rectangles, where all angles are right angles. We looked at squares, which are a parallelogram with 4 right angles and 4 congruent sides. And we looked at a rhombus, which is a parallelogram where all the sides are congruent. Later on, we'll get into trapezoid. We won't be working with trapezoid today, but it is a type of quadrilateral and a kite, which we'll also get into later. But what we can do with this information is we can actually, like we did with the triangle, is classify this quadrilateral. So we want to identify what kind of figure this is, okay? And so, one second. Okay, so the first thing I want to do is identify, in this instance, do I have right angles? Are all these angles right angles? If all the angles are right angles, then I may have a square, or I may have a rectangle. If they aren't all right angles, then maybe I have a parallelogram or I have a rhombus. And so what I want to look at are all these right angles. And so the way I'll do that is I'll identify the coordinates and I'll write them for you. Okay, and then I want to do what I did when I looked whether they're right angles here, right? I want to identify what my slopes are. And if my slopes are negative reciprocals of each other, well, then I have right angles. And so I'll do that very quickly. So I feel like you kind of get the gist of it. AB equals 6 minus 2 minus, which gives me 4 over 4, which gives me 1. Okay, same thing. For this one, I want to do all of the different sides because I want all sides to be right angles, right? So I'm going to do all the sides. Okay. So I'm doing it for all the sides, and I want to identify if all my sides are right angles. Okay, and so now I want to see how these relate to each other. So how does AB relate to DC? So basically, I'm looking at this angle right here. How do they relate? Sorry, hold on. I meant to have to get that negative in there. So how do those relate? Well, are they negative reciprocals of each other? Well, there's nothing to switch, so I don't have to switch anything. But does the sign switch? Yes, the sign switches too. So that those are negative reciprocals of each other. And so I can check the next one. CDAD. CDAD. This one. Let's check. Are they negative reciprocals of each other? Well, they're not in a fraction, so I don't necessarily have to switch anything. But are my signs switching? Yes, they are switching, right? I have a positive and a negative, so those are negative reciprocals of each other. And so basically what I'm able to identify in doing this is that because these slopes are negative reciprocals, so yes, negative reciprocals, then yes, they are all right angles. So now I know they're all right angles. Okay, so knowing that they're all right angles leaves me with two types of quadrilaterals. It can be a square or it can be a rectangle, right? Knowing our characteristics. And so now how do we determine whether it's a square or rectangle? Well, what we have to do is now find the lengths of the sides. If all the sides are going to be the same, then we have a square. If two sides are the same and the other two sides opposite are the same, well, then we have a rectangle. And so a very condensed version of this is what you're going to do is you're going to plug the coordinates into distance formula, right? To find sides, we use distance formula. To find angle measures, we're going to use the slope formula. So plug the coordinates into the distance formula, and by doing so, you'll identify what each of the sides is. And so when you do so, you will find that this side is equal to 32, and this side is equal to 32, not square root of 32, square root of 32, square root of 32. And you figure that out by plugging each of the coordinates into the distance formula, right, for each of the sides. So you would test A and B together, you would test B and C together, you would test C and D together, and A and D together. And that's how you would find all the sides, okay? And so when we do that, we'll identify that because all four sides are congruent and all angles, oops, and all angles our right angles, then we can see here, we have 4 right angles and all 4 sides are congruent. Well, then we have a square. And so that would be a square. Okay. Any questions about this? Questions, concerns? Okay. And so here, if we're asked to find the perimeter of that, I'm pretty sure you know how to do that. Perimeter is equal to this side plus this side plus this side plus this side. If all those sides are the square root of 32, then you would just add them together. And when you add them together, you will get it's equal to 16 over the square root of 2. Right? You just do the perimeter. Once you know all the angle measures, all the side measures, you just add them together to find the perimeter. So that's basically what that's doing. Okay. Last thing we're going to look at is how can we prove that diagonals bisect each other? So there are some instances in which the diagonals bisect each other, like when we have a parallelogram, right? That's one of the classifications of parallelograms. And so how do we prove that? Well, the way we prove that is use the midpoint formula. So whenever we're asked to prove if diagonals bisect each other, what we're going to use is the midpoint formula. And this is something we've also worked with already, so it's nothing new. The midpoint formula goes like the midpoint is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. Right? And then you find the midpoint. So how would we prove that these bisect each other? Well, in order to prove that they bisect each other, then they would have to meet at the same midpoint. That's basically how we would do this. So I'll show you what this looks like. This is -3, 5. This is -1, 3. This is -3, 1. And this is -5, 3. Okay? And so what we would use is the midpoint formula. So we want to find the midpoint between this line. What is that point right there? You see how whenever those two diagonals bisect each other, so where they meet perpendicularly will be that midpoint. So I want to identify what is that midpoint. And if that midpoint is the same. If that midpoint is the same, then they bisect each other. If it's not the same, then they don't bisect each other. So they don't cut each other into two congruent halves. So we would test this. So I'll try Q and S, which gives me -3 plus -3 over 2 and 5 plus 1 over 2, which gives me -3 and 3. Okay, now test R to T, right? That's my other diagonal, which gives me -3 plus -3 divided by 2, 5 plus 1 divided by 2, which gives me -3 over 3. And so because I have the same midpoints on both sides, then do those diagonals bisect each other? The answer is yes, they do. So whenever we're working with diagonals, we want to use the midpoint formula. Okay, any questions about this? Concerns? No. Okay. So that being said, whenever we want to identify whether a figure on a coordinate graph is classified as is a specific triangle, is a specific quadrilateral, or specific parallelogram, whenever we're trying to identify the side lengths, we're going to use the distance formula. Whenever we're trying to identify angle measures, we are going to use the slope formula. And whenever we're trying to look at whether diagonals bisect each other, we're going to use the midpoint formula. And what we're basically doing is seeing how those side lengths relate to each other. The way that those side lengths relate to each other can tell us different things about the figures, like we saw in the triangle example. If all those sides don't equal each other or aren't congruent to each other, then we probably have a scalene triangle. If we have two sides that are congruent to each other, but the last one isn't, maybe we have an isosceles, stuff like that. The slope formula we'll use to determine if things are right angles, or if we have right angles in general for quadrilaterals. And then we'll use the midpoint formula to determine whether those diagonals bisect each other or if they don't. And if they bisect each other, then maybe we have a parallelogram, etc. Any questions? It'll take some working through, but basically that's the gist of how we can use these formulas to classify different figures on a coordinate graph as whatever figure they are. Yeah. Any questions? Okay. If there's no other questions, you guys may log off. Have a great weekend, and I'll see you guys on Monday. Bye, guys.